Good morning, everyone, and welcome back to the second day of our KOSMOS workshop. I hope you got some time to get some proper rest and recharge your batteries. So we're starting our second day with Rebecca Schaefer. It is a great pleasure to have her here today and talk about her research. Rebecca currently is an assistant professor in Leiden University in the Netherlands, and her primary research interests are the neuroscience of moving to music, music performance, and music imagination, aiming to apply these findings to rehabilitation settings. She has received MScs in clinical neuropsychology and music cognition from the University of Amsterdam and Kiel University. Her subsequent PhD work at Donders Institute for Brain Cognition and Behavior of Radboud University Nijmegen.
Yeah, close enough.
It took years to sort that out. And behavior, focused on developing cognitive tasks for brain-computer interfaces and specifically on decoding music imagery from electrical brain signals. Before coming to Leiden University, she held the SAGE Junior Research Fellowship at the UC Santa Barbara and the European Marie Curie Fellowship at the University of Edinburgh, UK, where she carried out research focused on the interaction of music and movement, individual differences in rhythmic ability, and imagery function. And today she's going to talk to us about auditory and visual imagination, perspectives from cognitive neuroscience. Thank you very much, Rebecca.
Thank you for the elaborate introduction. Thank you for inviting me to come and speak here. It's a really nice invitation with a nice mix of different disciplines, and basically for today what I hope is to give you the perspective of neuropsychologist / cognitive neuroscientist, because even though all these jobs that Georgina just mentioned, they were all in different departments, different disciplinary departments actually, but I very much come from the tradition of neuropsychology and thinking about imagery in terms of the cognitive, as a cognitive task and the implications that come with it. So I just want to start with this image because not only does it sort of, for me, give an idea of all the things that imagination can do, but I also see it a little bit as the potential outcome of this workshop, right? If you combine a lot of beautiful things, you can get glorious, novel outcomes. And I do think that's also a little bit how interdisciplinarity works, right? If done correctly, you can really get an extra dimension to understanding the concept that you're interested in. Excuse me. So for today, I'll basically talk a little bit about imagery modalities and imagery types, some neural correlates and how we interpret them. And a little bit more also on imagery ability and individual variation, and how imagery can also support other functions, which I think in the context of the sort of emotional processing that was talked about yesterday might also be relevant. I had so many thoughts yesterday during what was said, so I'll probably not be able to make all the links that I thought of then, but I'll try. And I think that there's just so many things that we can latch onto and that we can find cross connections. So yeah, I guess that's just a reiteration of saying I'm excited to be here. Okay, so of course, one thing I also really liked was Georgina's call for order in the chaos. So I thought I'd start with something of a taxonomy, if you will, just so that we can get a bearing on terminology and on different phenomena or different aspects of imagery that might be distinctive in terms of categorizing them in different ways. And the first sort of most obvious, or for me anyway, from my background, one of the most obvious ways to do this is to look at modality. So what senses are involved, and of course, well, we've already talked about this. I think there are some niche research projects on olfactory imagery and gustatory imagery, and they're quite exciting things, but really very little still to think about. But we can also think about this in terms of more dimensions, right? So if we have spatial aspects, and so there are spatial aspects in movement imagery, there are spatial aspects in visual imagery, but there are, for instance, temporal aspects as well that are more likely to be in things like movement or music or sound, just simply because they have a time dimension, unless, of course, you have a moving image, which also includes time. And in general, it's quite artificial to divide these up in discrete. I mean, basically what I like to think about is more like what kind of elements are there in an image, and how can we classify that. Now, what I've become really interested in is also the different types of imagery. And so Georgina already mentioned this a little bit yesterday. Well, we can basically, when we look at at least the psychological literature, we see imagery defined as a lot of different things. So in general, we'll see things like, the active awareness of a percept in the absence of any sensory income, right, or sensory signal. But really, if you look at some of the literature, it's a wide-ranging set of phenomena that are all brought into the context of imagery. And so we might think about anticipatory imagery when you're about to strike a piano key, you already hear it a little bit, or how we interpret incoming information. So this is also the type of imagery during listening, which has already been mentioned, but also things like multimodal associations. So the audiation processes of reading sight music, reading music notation if you've done this a lot, right? Or people who associate movements with sounds if they have highly ingrained multimodal coupling. Of course, the spontaneous dimensions are really interesting and also very relevant to this workshop. But even things like rehearsing a phone number before, well, we don't do this anymore, but trying to remember something for a while, it engages these processes that you could consider to be imagery. And that's all aside from this kind of deliberate active imagery that psychologists have been working with in experimental settings for the most part. And so you can already get some idea of, like, is something conscious or subconscious, so sort of the prediction of action outcome. You can think, well, this is not really something that you think about all the time, but it's just an association that's there. And so when going through these different types of phenomena, what I started to do sort of implicitly is to organize these types in a space of degrees of awareness, which we see here on the x-axis, and the sort of intentionality, so how automatic towards effortful. And then you might organize these different, and this is clearly just a thought right now, right? So I'm not presenting data or anything, but so something like action outcome prediction is very automatic and quite subconscious, and interpreting incoming stimuli is not something that we have to actively work for, that's just part of the apparatus. Right? But so multimodal associations you'll be more conscious of, but it's still happening quite automatically. When you retrieve something from long-term memory, you might experience it, but not think, oh, now I will imagine, right? I mean, that's not an effortful thing. And so you might think about these different aspects in different ways, and I won't go through all of them, but you can sort of see where I'm going. I think that there are these different dimensions that we can distinguish that might bring these different phenomena together. But we don't really know if it's actually the same function, and or if we could expect these to be similar in terms of neural processes. Okay, so I also got really interested in sort of seeing how, in philosophical terms, people were thinking about different types of imagery. And actually, I was drawn to this work by P.F. Strawson through a really nice PhD thesis by Margaret Moore, who discussed different kinds of imagery for specifically for music. So in Strawson's work, it wasn't specified for music, but that's basically what Margaret did. And she talked about the four types that he distinguishes are sort of perceptual imagination, which is sort of the deliberate sensory stuff, but also something he termed constructive imagination, which is a little bit of a complicated, or sorry, ambiguous term because it's also being used for sensory imagination in the sense that you construct an image. But here he really means sort of the organizational, the ability that organizes information for perception. And so basically allowing coherent cognition and understanding of the information that comes in. Which is, of course, really close to this sort of imagery during listening that we've talked about before. Now, the other types that he distinguishes are creative imagination, which is just more like recombining new things, right? And then propositional imagination, which you can see as sort of the what-if scenarios, right? Pretend I'm your brother, something like that. And of course, it's something that you would have to work hard to do. And so in this case, the constructive really caught my attention because it sort of captures these automatic processes. And when I was thinking about the mind-wandering element yesterday when you were talking about this, is actually like, it seems like all these different types of imagery as Strawson describes them, could be elements within the sort of spontaneous thought that happens. So when we think about deliberate sensory imagery and imagination, of course there are some commonalities, right? So the image can retain the structural properties of the percept, but it appears to do so in symbolic form, right? And then when this reduced symbolic form, that would then be the link to other symbols and ideas, which then could be the source of sort of the larger images that are elicited. And so I don't know if this is perhaps my version of sound object processing in the way that it was talked about yesterday, but just to give you an example, if you would hear something like this, and it has all these sort of physical properties, but the mind doesn't really care about these physical properties, but it maybe extracts something like this, but then adds some influences from the performer, right? So there's something that makes it more biologically oriented. But for a lot of people, it will go straight to some other association that you have with this specific kind of, with this specific sound object, to call it that way. And so there are elements of categorical perception, but also, of course, memory processes, and these all work together to sort of, lead to this representation. And so focusing a little bit more from this psychologist's point of view, right, on mental representations, you're probably familiar with this picture, the duck rabbit. I thought it was a nice example because in the mental representation realm, we don't really have ambiguity, right? We can't see the duck and the rabbit if it's a representation, and not in the same way when it's an actual percept and the signal is there and you can sort of switch back and forth. And so considering these representations, it contains sort of the most salient aspects, and what those are, that might depend on the listener, right? And consist of these modality-specific dimensions. And then that representation will lead to others, right? It has connections and associations, and these are probably highly personal, but when we have sort of a shared background or some shared surrounding, right? This will also allow communication, because these, the set of associated ideas that we might all share if we come from a similar culture or similar age group or similar whatever, this also allows using these mental representations to actually communicate. And so I've been thinking about imagery as a mental model for a while now, where basically it can follow all, it can have these different roles, where in the subconscious we need these internal models to sort of understand what's going on, right? We need to have some sort of template to match the new information to. And that might lead to being able to track music over time, or being able to recognize a visual object. But also the mental model idea works in the conscious realm, where it might not be deliberate, but it still supports and it also supports other functions, so such as the working memory example, and also yeah, almost like a theory of mind, right? You have a model of what somebody else is doing. This is only happening in your head, right? It doesn't actually mean that you know what somebody else is doing, but you are interpreting behavior this way based on these models that you have. And then when it comes to the deliberate and active imagination, then it's really this active simulation, right? Where you heavily depend on how well you're remembering something, and as to how well you can reproduce it. And so I felt that these ideas lined up really nicely with sort of ideas on predictive coding that have been floating around for a little while, and were described really well by Andy Clark in his 2013 paper, where he basically unifies different cognitive functions by defining them in terms of prediction error. So that if you have a certain model that is then confirmed or adjusted by new information, that leads to model updating. And when this happens at multiple hierarchical levels at the same time, it's sort of a conceptual model of how the brain works. So I won't read out the entire quote, but I think you get the idea. And the core ideas to take away from this are that both perception and movement are shaped by predictions and our expectations. And that our models also drive what's interesting, right? So if so the salience of what we have to attend to, and also so this is really also related to this concept of constructive imagination that I mentioned before. These models are built up through basically probabilistic learning and sort of our ideas of the statistical surroundings that we are used to. And like, as I said, so this maximizes attention for things that are not expected or not modeled previously. And so this also helps us to distinguish situations in which we just have no idea what's happening, you know, where you might not be able to predict something, where from a situation in which something just highly unlikely is happening, where your predictions are actually being violated. So I thought this was a really nice way to conceptualize also how music, specifically for the case of music, where we have these long-standing ideas on how predictive processes sort of form the core of how we understand music and how we appreciate music, how it leads to emotional effects. Together with somewhat, well, there are some older ideas, but also somewhat more recent on how imagery processes might take the role of, you know, this whole predictive processing apparatus. I've tried to combine these ideas a little bit to say, like, okay, the mental models that we have are the origin of the predictions that we generate, effectively leading to musical understanding and emotions. So I think in this way you sort of unify a lot of different ideas from cognitive science as well as music cognition, with a fairly central role for imagery. This may be my bias, but of course, I think this works together very well. Okay, so when we get to actually researching imagery, things get extremely more complicated. So of course we can look at the brain in the time domain, and we can look also in space, so where things are happening. In general, as you probably all know, working with imagery is exceptionally complicated. I'm probably preaching to the choir here, but so we have very little to no control over whether people are actually doing the task, and even checking for it already influences it. If we have to be really careful how we instruct people, right? I once did some work on rhythmic imagery and then found out that yeah, there was lots of different strategies. People were counting, people were imagining bouncing balls, and so to really unify what people are doing in these imagery tasks, we need to be really specific in our instructions. On top of that, a lot of the measures we have are not validated very well, the types of questionnaires that we use. And most of all, like, it's a highly unnatural situation, right? If I'm asking people to imagine music with their head in a giant magnet, well, you can wonder about if there may be other things that are happening, right? And then I'm not even touching on the spontaneity element. So that's for the brave souls like Georgina who are doing brain imaging of spontaneous imagery, which I haven't even dared try yet. So, given all these difficulties, then you have to keep these in mind when you're looking at these brain results of imagery. And of course, we tend to look a lot at sort of the primary sensory regions, but of course, music elicits a lot more activation than just auditory. So I took this nice figure from which Teppo Sarkamo sent to me from their recent review in Lancet Neurology, where they summarized a lot of the different areas that have been found to be related to music listening. And so he sort of categorizes these into all these different aspects of music processing that are happening. And basically, whenever I show this slide, I'm trying to just give the message that it's sort of all over, right? There's just a lot going on, and it's not, yeah. When we say, well, imagery is like perception, well, in what way, right? So and where and when and all those things. So what we do know, oh, actually, sorry, I meant to say here also that if we're looking specifically at model updating and model creation, then a lot of the motor areas become really interesting because that's a large part of what they do, so basal ganglia and cerebellum. So these have actually, for me, been sort of core interest in my own work. So we know that there is, like I said, overlap in these modality-specific areas between active perception and imagination, and generally it's a little bit weaker during imagery than during perception. And aside from the visual modality, what we tend to see is that it happens in secondary auditory or secondary sensory areas, which the findings are sort of inconsistent, but it might be that visual imagery is special in this case. It might also be that just the organizational process or the constructive imagery, if you will, is different for the different modalities. And this recent, fairly recent paper, also from Nijmegen, showed this really nice study of trial by trial vividness differences, showing that actually the trials that are rated as more vivid also show more overlap between the perception and imagery conditions. And so for me this was a nice example of sort of what the advancing methods in neuroscientific research can actually tell us when we can move away from sort of large group averages and really start looking within people, within single subjects, and even between trials within single subjects. Some of my own work from a few years ago, we did a sort of a meta-analysis on a lot of the EEG data we had by that time, and actually what we found then is that the overlap or the shared activation between perception and imagery seemed to actually reduce with the complexity of the material. So if you have a basic sort of rhythm task, then there's a lot of shared activation, whereas once it gets to sort of holistic natural music, then we didn't find as many overlapping components as with the simpler tasks. So this also shows that this overlap is variable and dependent on multiple things. And so at the time, I was thinking about what causes this overlap, and of course this is again just thoughts and not data, but you can think about what kind of bits of sort of active perception might also be a part of imagery. So, for instance, in the imagery you have to actually perhaps generate the subjective sound in your head, and in the on the perception side, you actually have to receive the incoming information, but all the rest, the sort of the tracking the tempo, detecting regularities, generating your expectations, this might be a core part of what this overlap actually does, or what it is related to. And you can imagine that this also varies with vividness, or perhaps attention. Maybe we'll hear more about this in the next talk, but also in the type of material that you're imagining. So we have all this modality-specific overlap, but of course there's also sort of more task-related aspects of imagery. And so when you're deliberately imagining, you can see there's certain components that are involved, such as long-term memory retrieval, just figuring out what it is you're meant to reproduce in your head, but also concentration. And so there was a study already a while back looking at the commonalities between visual and auditory imagery, and using actually non-musical materials, but just cueing a word and then either imagining the visual or the related sound. And very interestingly, they showed there are a number of regions in the brain that don't really respond to actually perceiving these things, but are activated in relation to imagining, and not really distinguishing so much between auditory or visual material. Actually, I mean, I didn't want to elaborate too much, but there's some really nice work by Karamazza on sort of conceptual processing of concepts that shows up in a lot of these sort of parietal areas as well, and which I thought was maybe a nice addition to this whole pictorial versus more conceptual discussion. So maybe there'll be some new input on this debate at some point. So then you have the modality specific and you have the modality unspecific, but this is still not looking at what people are actually imagining. So what is the imagined material? And so just as a few examples, we've come to the point now, and like I said with the vividness study, we've come to the point now where we can actually look within single subjects and specifically with decoding methods have a better idea of what is happening specific to certain images. So we see this in the visual domain where people can, where we can predict the response patterns to objects that have already been seen, but also so the imagined objects that haven't been seen yet, but in this case also have auditory instructions, so I was tickled by that. In the movement domain, we can start to distinguish different imagined actions, and even this interesting recent paper looked at auditory emotions, but they basically meant voices, so it's more linguistic content. And they found a whole range of areas involved in auditory as well as tactile imagery that go way beyond the sort of modality-specific regions that we're used to seeing these activations in. So in my own earlier work, just looking at, again, averaging now over participants, looking at different effects of what somebody is doing, namely imagining or perceiving, versus what they are imagining or perceiving. So I'll talk you through this graph a little bit. We found that the occipital alpha response was actually most interested in this task, where if you look at the figures on the left, you'll see the averages over the whole group, where on the top you see the two conditions in the difference plot for perception and imagery, and on the bottom you'll see the two conditions for the stimuli, where we combine imagery and perception. And you'll see that there's an effect in the task comparison, but not in the stimulus comparison. The reason to put in all these other single subjects here now is that when we do look at the when we do look at the stimulus at the level of the single subject, we see that this occipital alpha response sometimes goes one way and sometimes the other, or doesn't do anything, as in this case. I'm trying to think, I probably have an example of a sound stimulus of what people were actually imagining in this case. So I think the first stimulus they had to imagine was the Tchaikovsky clip that you heard before. The other you'll hear in a second, and the setup was that we would play this tune, which really a short phrase, and then ask people to imagine and then listen to it again, and imagine and listen to it again, so that we could have this alternation of perception and imagery. So this is faded a little bit. They get the idea of the repetition. So you get the idea. So people were sort of alternating in their perception and imagery. Also, this is honestly a way for an EEG study to just get a lot of trials. Thank you. But it becomes comical after a while. But you can sort of see how this setup works. I was early. Intrigued also by, I found that a lot of people had motor strategies to keep themselves in time, so that's a sort of an anecdotal observation, but something I would still very much like to follow up on. But the point here to make is that the correlates of task appear to be more uniform than the correlates of stimulus. So we made a first effort to also start looking at the actual content in the music itself by decomposing the EEG according to musical features, and we do this by making. I'll have to play that again. We basically made a model of different types of things that could happen in the music. In this case, we modeled aspects of the rhythm, because they worked really well, and also whether a contour was going up or down. And then somebody would hear a melody and then have to repeat it with in their heads on the timekeeper that was given. So. And the reason we put in this timekeeper is just because it's always so tough to make it time locked, right? And really know when people are imagining things. And what we found is after decomposition, so on the far left you see the non-decomposed data, so there's the original data, but once we started decomposing it, actually the correlations between perception and imagery started to increase. So this suggests that there are some common representations, and again, this is a group average, so we're not really learning about interpersonal differences, but it does sort of get at that similar things are happening related to musical aspects in perception and imagery. So looking a little bit more at these individual differences, we started to do larger scale questionnaire studies, and for those of you who aren't familiar with all these acronyms, basically the VVIQ it's a visual list. The BQMI has all the BETS has all these different subscales. The BICE and the KAIS are both auditory lists. Then the VMIQ and the MIQ are movement imagery lists. The OSI-VQ and MOSMI both include spatial imagery scales, which was my collaborator at the time was mostly interested in. And we had 300 US college students fill in these questionnaires and started to look at whether how do these different types of imagery how are they related to each other? How do they relate to experience? And there we found quite nicely that dance experience or dance training related to higher movement imagery abilities. Gaming, video game playing had an effect with spatial imagery, and music experience led to higher music imagery ratings. The thing to also remember is that this is all self-report of vividness, right? So these backgrounds might also just lead to more confident answers. But what we were most surprised about is that how related everything was to each other, and that a lot of the scales that were meant to measure the same thing actually didn't relate to each other as well as some of the cross-modal ones, which is sort of a sore spot when it comes to thinking about the validity of these different lists. So we're still working on figuring out how to really say something about this data that sort of goes beyond just validating all these lists again. And in a more recent study that Georgina's also worked on, we basically took not quite as many lists, but we widened the participant pool a little bit. And again, we found this really high interrelatedness between different imagery modalities. And here we only found a weak relation with the expertise. And here one of the things I thought was very interesting was that if you take the age range from 18 to 65, that we actually didn't find a decline in self-reported imagery ability. So this is with all the stuff that we get worse at with age. Imagery does not appear to be one of them, which I think is always a nice thing when something doesn't get better, it doesn't get worse. And this also sort of leads me to this idea of imagery supporting other functions, right? So in my own work, first I was really interested in imagery mainly because we were looking at it as a covert task that might be used in a brain-computer interface. And I've been sort of working with this idea basically all the time, where you're thinking like, how can we harness this and how can we use this? Because we all seem to be equipped with this machinery to simulate and to imagine, but it's hardly being capitalized on for health purposes or well-being things. And you see more and more that that now this is happening. I think we will hear more about this also in this meeting. But the types of functions that are aimed at, that we aim to improve are things like memory, where you do lots of simulation, exercises, movement, which is really the domain that I'm in right now, where we're trying to see if we can regularize movement by imagining music. And of course, various types of learning, right? So this could be mental rehearsal in a music setting, or a motor learning in our particular case. And it could be that imagery is sort of a necessary component of some of these processes, right? So when it comes to working memory or those sort of things, well, we're pretty sure that the imagery processes are a part of those. We had a nice example of a piano masterclass where a teacher called Nelly Benor, she made her piano students just imagine entire pieces until they knew them very well, and then through that sort of arduous exercise, then really reducing the cognitive load during performance, where it's in this case not a spontaneous strategy, but it's very helpful in the sense of freeing up cognitive energy while you're performing. But in these cases, it tends to be really rich, multimodal imagery that has a lot of links with different things, and we can include kinesthetic, sort of proprioceptive feelings, we can include visual images, we can include emotional imagery, right? Some of the work that I don't have time to report now, but some of what I've been working on recently is how we use images in music performance, right? So how does saying play it with fire, how does that change the way we implement things, implement the movement? And so these, there are a lot of both clinical and pedagogical applications, and I'll go really quickly through some of these results that we've found in the last few years, where I have an example of moving to imagined music measured with fMRI, where basically people were lying back in the scanner and doing wrist flexions like this, because of course you can't let them move too much when they're being scanned. But this is what they would hear. Basically people are lying like this, and eventually having a hard time not also moving their feet. And we selected this clip because it was actually relatively easy for people to imagine. It has a lot of little things happening. There's some rhythmic complexity. There are some voices but no language, and it's in both male and female range, all these sort of things. What we found when we looked at the cerebral activations is that for music, as compared to moving in silence, we saw this cerebellar activation. Whereas when moving to imagery, we see basal ganglia and superior motor, supplementary motor area, which, well, the supplementary motor area is basically just a sort of a sequencing mechanism, but both these cerebellar and basal ganglia findings were really interesting to me, also for these model updating reasons that I mentioned before. Really briefly, also in EEG, and this is quite recent, we did have people do a sort of a complex finger tapping task with a visualization like this. Right, so, well, you can't see all the lines, but there's different lines where people basically follow it with their fingers. Play it all, but the idea was that after a while you take the music away, they do the same kind of task, and they do it so with either without any music or while imagining or while listening. And we very interestingly find that in the beta range, where you would expect motor related responses, that whether people are, so on the left is imagined music cueing, and then the actual music cueing, and then moving in silence, which it's highly significantly different. We see that actually imagining this music elicits a lot of motor processes that are very similar to when people are actually hearing the music. So this is still a work in progress. Interestingly, some of the alpha responses that I showed earlier, they don't show up in this context, which is within the context of moving. So that'll be another interesting thing to think about. And we also use this paradigm in a learning study, which Ayesha will tell you more about today. So if you're interested, I'll encourage you to go and see her poster. So to summarize briefly, there are some, so the diverse types of imagery might be unified by thinking about them in terms of mental models, and also varying the degrees of awareness or willfulness. I won't read out everything, but this idea of seeing them as mental models also allows for interpersonal differences that are basically built up through our autobiographies and sort of our experiences, with shared experience leading to more shared models. And this, in this way of looking at the brain as a prediction generator, sort of unifies perception, cognition, and action. And I think that there's a specific role of imagery there, or constructive imagery anyway. So then for the second part, there are also modality unspecific parts of imagery that are likely related to what kind of imagery we're looking at. And of course, and also the different modalities might share these. This might lead to this high interrelation between the self-reporting abilities between different modalities. This interesting sort of recent finding that it doesn't seem to decline with age, which also implies that it's not so much an executive sort of attention-driven function as we thought it was for a while. And so I think there are some nice applications in the pedagogical and healthcare domains, which I hope we'll hear more about also in this workshop, which I hope we will bring together all these different views of this magnificent phenomenon that we can look at from so many different sides. Thank you so much.
Thank you very much, Rebecca, for this really interesting talk, putting everything together, but also giving us ideas for new things. I had lots of notes for our manuscript in preparation. We have some time for a few questions. Does anyone? I have a question. You talked about individual differences and how they might affect vividness, and we have explored the role of experience, expertise, and this factor, and we can't find that much of an association there. But there is some in some cases. Do you have any ideas about what other individual differences might contribute to that vividness, higher vividness imagery abilities? Like, let's say, how many books they were reading as children, or into how much music they were exposed as children instead of the training.
Yeah. So I think a lot of this relates to our measurement instruments, right? So if we are working with self-report questionnaires, I think it's quite important and valid to do this, but you also have to keep in mind what the ramifications are, right? So we already know that, because in this first huge study with all the different questionnaires, we also included a social desirability questionnaire, where we're basically just measuring whether people are giving us answers that they think we want. Right, because this is also a big issue, of course, in this type of research, where you're just like, "Are you imagining it?" And somebody's like, "Yes," right? And so I think what we found was, interestingly, I mean, it's not a core finding of the thing, but that the male part of this group was much more confident about really obscure kinds of imagery, like the olfactory and the gustatory, and we're like, so why would that be a difference, right? And so I think there is definitely some part that's just related to confident answering. Right, so that doesn't answer your question, but I think what would really, we find, so when we do cross-sectional stuff, right, we find differences between experts and non-experts that are just there. It's just so, but we're generally not able to do those kinds of tests with larger groups that really look at these kinds of influence that you mentioned, like education level, or So I think we're just using different tools to answer these same questions, and that would be my my impression where most of these differences come from.
Thank you. Anyone else? Yes, Constantina.
Thank you very much for your very nice presentation. I have a very spontaneous, actually, question. I'm coming, let's say, from the research area of synesthesia.
Oh, right.
And in synesthesia, is this, I find, maybe it's different phenomena, but I find really many commonalities, actually. And in synesthesia, many scientists say that we have low and high synesthetes, people that have weak synesthetic experience or strong synesthetic experience. And I keep wondering if this weak form of synesthetic experience through
some sort of cross-modal association.
Exactly, visual or auditory imagery processes are underlying, let's say. Because what you said about the visual cortex, for example, that imagery happens in the secondary visual cortex. It's the same with synesthetes and grapheme color synesthesia, that when they see letters in colors or numbers, then the secondary visual cortex is associated or activated. So what do you think about that? Or
so the first thing I thought when you were talking was that I really appreciate this spectrum of sort of weak and strong. So what I failed to mention in this in this particular study, in the bottom one, we also included this EMIS, which was very well developed and validated by Georgina here, and the SUIS list, these are both lists on spontaneous imagery, so spontaneous visualization, spontaneous music imagery, and I think, well, also in our discussions, but we've been coming to a point more and more that it's not so separated. Right there, it seemed there, especially in the earworms, we seem to be able to go back and forth a little bit between what's really spontaneous and what's just sort of happening in the background, right? And I think that coming back to your point about the synesthesia, I think it might be one of these things where if the association is made early enough, right, that it sort of holds. I seem to remember something about the colors in toys, right?
For example, yeah, or in the books of alphabet, letters, and that kind of stuff. Yeah.
Yeah, and so actually that might tie into your question again, like where you know, if you have a strong early association, a coupling there, that will put you somewhere on the spectrum, right? And maybe everybody has this spectrum.
That's another, of course.
Yeah, but how that ties into the sort of secondary, more organizational function of secondary sensory cortices, I think that's an open question. I don't have an immediate answer for that.
Yeah. I was just, it was a spontaneous question, as I said. Yeah, okay, thank you.
We have time for one more question. Rolf?
Well, thank you. My question is about volition. How do you trigger images? And it has a very practical background. Having, as I mentioned yesterday, been teaching orchestration in my previous life. Of course, the challenge is to predict what this sounds like. And also, I was teaching solfège, ear training. So you have this very concrete task where you are supposed to please imagine this or that. How do you do it? It's the big question. And as I tried to show yesterday, that there are some indications from, not from the primary neuroscience perspective, but from the more behavioral perspective, that because of the linking of motion and sound from past experience, it might work. But I am afraid to generalize. So have you any thoughts about volitional imagery?
Yes, I have thoughts about that. So I think it really depends on the situation. So in some cases, like the solfège, I think it's a learned association where you've, I mean, when I did training like this, they would teach us the first interval of a song, right? So if you can remember and imagine the song, then you can you have this interval at the ready when you need it. And there it seems to be more of a memory thing. Whereas with the movement, so in our studies, we tend to ask people, even before we had these nice measures of sort of how much spontaneous imagery do you have, we ask people like, so when do you experience imagery? And many of them would say while walking, right? So walking provides this pace, and people just start making music in their heads while they do this. And I think the movement and especially the rhythm there, I would interpret this as a strong cue to sort of, when there's some sort of periodic thing happening, that this elicits these other sort of rhythmical cognitions, and that would be my interpretation. But I think, well, it depends a little bit on the imagery, right? So the earworm work at Goldsmiths has been trying to figure out what triggers these earworms, but also the other types of imagery, right? You're in a supermarket, you hear a song you know, and you walk out, and it's with you for the, even if the music cuts out for an announcement or something, and it's still going in your head. These are quite clearly triggered, but not necessarily volitional, right? So I think there are a lot of answers to that question. Yeah.
Okay, we're done. Let's give a big round of applause to Rebecca again. Thank you very much.